Hello world! Welcome to the Dino Mega Integration Guide. This guide is a curated collection of step-by-step videos that show you how to integrate and connect my Unreal Engine assets together, so you can combine features in powerful ways and open up a whole new world of gameplay possibilities. The videos in this collection will focus on the glue that connects the different systems together. They assume you're already familiar with the setup and basic usage of each of the assets. Our goal in this first lesson is to make the different window widgets work with each other and share the mouse cursor and input mode. For example, if you open a UI window from 2 or more systems, then close one of the windows, we lose our mouse and our input changes. This is what we are going to fix. You do not need to have all 3 of the systems to follow along with this video. The way I'm managing the code makes it easy for you to skip the parts related to the system you are not using. Before you start, you will want to make sure you have the assets you are using installed in your project and you have completed the setup instructions for each. If you need to, pause this video now and go watch those first. In this lesson, I will be using version 4 of my inventory system, version 2 of my quest system, and version 1 of my experience system. These assets have been added to my project, and I have installed each asset's main component to my player controller, per the instructions in the setup guides. Let's get started by first taking a look at what we are about to fix. Press play, then press I. This will toggle the inventory, then press L, which will toggle the quest log, and I can click the XP bar to see the XP window. Now watch what happens when I close one of these windows. It doesn't matter which, we lose the mouse cursor and our input changes back to the game. The reason this happens is because the systems don't know about each other, and they handle what to do with the mouse and input when one of their windows is opened or closed. The result of this affects the windows still open by the other systems. What we want is if any window is still open from any system, the mouse and input persists. When all windows are closed is when we want to hide the mouse cursor and change our input to the game. Instead of making changes inside of the included files, we are going to make a brand new actor component that we then attach to our player controller. You can create a new actor component from the new blueprint screen. I'm going to call this new component AC_Dino Mega Integration. And I'm going to add it to my player controller, then open it up. Let's do a quick test to make sure everything is connected properly. From begin play, do a print string, then press play and make sure you see your print string text. If you don't see it, then you did not add the component to your player controller. If you need to, add it now. When you are ready to continue, head back inside the component and delete the print string. Here's the plan for this component. Each system offers event dispatchers, which will be called when a window for it is opened or closed. We will listen for calls to these event dispatchers, and when any of them hear something, we will run our own custom logic, which will see if any of the systems has any open windows. We will then handle updating our mouse and input based on the result. We now know what we have to do. Next is when we do it, as in when do we want to start listening to them. The answer is right away, so we will be starting from our begin play. I like to keep my event graph slim, so I'm going to create a new function, and everything I want to do on begin play will be handled in there. I'm calling this function setupComponent. Connect the new function to the begin play node, then open it up. This function will have 2 jobs. First, gather all the references we need, and second, use those references to bind to the event dispatchers. What we do when those event dispatchers are called will live somewhere else. This function is just about getting everything wired up and ready for us to work with. I am going to use a sequence node at the start to help keep our graph clean and organized. We will use the first execution path to get our references, and the second is where we will bind into our event dispatchers. Since we need references for each of our systems to make the bindings, we are going to start there. I'm going to create another sequence, and we will use an execution path for each of our references. Now we know our end goal with this is to change the state of the mouse cursor and toggle our input mode. We handle both of those from our player controller, so that is the first reference we need. Since we attach this component to our player controller, we can get that reference by calling getOwner, then casting that output to a player controller. We want to then save the player controller reference, so promote it to a normal variable. For those working in a multiplayer game, there is an important step that you need to do at this point, and that is to make sure the rest of this function is only running client-side. This is because the parts of UE, like the UI and mouse cursor, are only client-side. To make sure you are running only on the client at this point, use in his local controller check. If it is true you are the client, great, but if it is false, you are the server, and you should do an early return, as the rest of the function is irrelevant to the server. To help keep things organized, I'm going to add in some comments. That way it is easier to understand what is happening if we happen to come back into this section down the road. These next paths on the sequence will be used for each of the different systems. And if you didn't have one of these systems, you would just skip the part for it. The next reference we need is to our inventory system's HUD. This is where the windows for the system are managed. Using our getOwner node, I am going to make a call to getComponent by class, then select the inventory system component from the list. Then, from the output, I am going to call the getHUD function, which returns the reference we need. Let's promote it to a variable called HUD_inventory. Hook it up to the second execution path, then add another pin to the sequence node. Next up is our Quest System's HUD, which is where the Quest windows are managed. Just like we did for our inventory, we are going to use the getOwner node along with a getComponent by class node. This time we are selecting the Quest System Player Controller component. From this component we can get the Quest HUD variable. Then promote it to a variable called HUD_Quest and hook it up to the empty path in the sequence node. Tidy up your graph, then add another pin to the sequence node. We will use this path for our Experience System component. Just like the others, use a getOwner and getComponent by class node and select the Experience System component from the list. Our Experience System doesn't use a HUD, but has our event dispatchers in the actual component, so we will save a reference to this component instead. Promote it to a variable called AC_Experience System. Hook it into the execution path and clean up the graph. It is important to keep in mind that what we are running here occurs right on the begin play, and our inventory and Quest systems dynamically add our HUDs during this begin play frame, so the references may not actually be valid right when this code runs. This is referred to as a race condition. We want to check for this and make sure they are valid using as valid nodes. And if any of them are not ready, we will use a timer to rerun this function. Hook all of the not valid paths up to a reroute node. Then create a setTimerByEvent node, and from the event pin, drag off and select Create Event. From the list, select the function we are in, which is setupComponent. Then set the time on the timer node to 1 second. Then after we start this timer, we want to call another early return, since we don't want anything else in this process to run. We will only continue when all of our references are ready and valid. I'm going to add a comment here so we know why we are doing this if we come back in the future. I'm also going to add some color-coded comments over each of our different systems references. We will use the different colors when we are working with each different system. This will make it a little easier to follow from a bird's eye perspective. Those are all the references we will need. Next, we need to bind into our event dispatchers. But before we do that, let's make sure our code is running properly by putting another print string on this other execution path. This print string will only print if all of our references are valid, and there it is. We are safe to continue. Head back to the graph and delete the print string node. Now for our event dispatchers, we will start with inventory. Drag in our HUD inventory reference, and from it select Bind Event to OnWindowOpen. This is the one that is called when an inventory system window is opened. We also need to bind into the one that is called when the window is closed, and that is our Bind Event on window close. Both of these nodes need an event, so drag off from the first one and select Create Event. From the list on the node, choose the Create a Matching Function option. I'm going to rename the function it makes to OnInventoryWindowToggle. Hook another Create Event node up to the window close binding and select the function we just made. Now when a window is opened or closed in our inventory system, we will get a ping, and it will run through the shared function. Connect it to the execution path, and I'm going to place a comment around this section and marking it with our color for the inventory system. Before we work on the logic inside the function we just made, let's finish setting up our bindings for the other two systems. Next is for our Quest system, so drag in the HUD Quest variable, and from it we want to bind event on Quest UI Open and bind event on Quest UI Close. Let's hook up our Create Event nodes, and from the list you may notice we can't select the same function we already made. And that is because each system works a little differently, and the inventory system is actually passing a reference to the window, where the other systems don't. Go ahead and let the node create a matching function, then rename it to OnQuestWindowToggle. Make sure you hook the Quest Close event up to this same function. I'm going to wrap these two nodes with a color-coded comment for the Quest system. Then for our Experience system, we use our AC Experience System variable and bind event to UI Experience Window Show for the opener and UI Experience Window Hide for the closer. Make sure you hook everything up to the execution path. Connect up the Create Event node. Now we could use the same function we created for quests, but let's keep everything similar so it is easier to understand in the future, and let the node create a matching function for us. Rename the new function to OnXPWindowToggle. Use the same event for UI Experience Window Hide. Then add a comment around this section for the XP system. Now, each system calls a function in this component when a window opens or closes. Since they all need to do the same thing, we will create and call a shared function that we relay all those other functions into. This shared function will be named checkWindows. Now go through each of your window toggle functions and call the checkWindows function. This is the function where all the magic happens, and it won't actually take very much to do what we need to do. It is all about the journey with this one, but before we continue, let's make sure everything is still working smoothly, and we'll do that with a print string. Place this print string at the start of your checkWindows function. Press play and try to toggle each window. You should see your print string when you open and when you close each one. If any of them don't show it, check to make sure you connected the checkWindows function inside of the window toggle, and also make sure you are binding into the events, not unbinding. We can remove the print string now that we've confirmed that everything is coming through properly. This is going to be a short function. We only need to do two things. First is to check to see if any of our systems has an open window. Then we are going to use that information to decide if we should toggle our mouse and input modes. I'm going to use sequence nodes to keep everything easy to read and organized. First up is our inventory system, and from our HUD inventory reference, we can call the function any windows open. This gives us a bool, true if there are, false if there are not. I'm going to promote this to a local variable called this inventory windows, then hook it up to our first path on the sequence node. Next is our quest system, and from our HUD quest reference, we can call the function has any open UI. Then I'm going to promote this one to a variable I call this quest windows, and hook it up to the next path in our sequence. Last, we have our experience system, and this one works a little different than the others since there is no HUD. For this one, we want to get the UI experience window variable. This variable is set when the window is shown, and it is unset when it is hidden. We can convert our UI experience window variable into a validated get by right-clicking on it and selecting the option. Now, only from the isValid path will we check to make sure the widget is visible, and we'll feed that result into a local variable we call this XP windows. Make sure everything is hooked up, and then add some color-coded comments around each one. Now we just need to evaluate this, and that is how we determine if we should show our mouse cursor and what to change our input mode to. Drag in each of our local Boolean variables and hook them all up to an OR node, then connect the node to a branch. This branch is basically asking, are any windows open in any of the systems? If there is, then we know we want to show our mouse cursor and change our input mode to game and UI. If there are no windows visible, we want to make sure our mouse cursor is hidden and our input mode is set to our game. Drag in our player controller variable, then from it select Set Show Mouse Cursor. For our true path, we will set the value of it to true to show the mouse cursor. For the false path, we will set the same variable, but to a value of false to hide the mouse cursor. Next is the input mode. From the player controller variable call Set Input Mode Game and UI for the true path. Then for the false path call Set Input Mode Game Only. Tidy up your graph and then add some comments to make it easier to follow down the road. When you are ready, press play and try it out. If everything works, you should see the mouse cursor toggle and the input mode change and all systems are being accounted for. If it is not working, the issue should be within this checkWindows function, since we tested to make sure everything was flowing properly before we coded it. Now that you have the UIs working together, you can jump to any of the other chapters in this guide. Each chapter focuses on topics related to two specific systems. For example, if you wanted to learn how to merge the interaction systems included with both the quest and the inventory systems, or make item quest rewards, you would find those videos in the inventory and quest system chapter. If you have questions or requests, you can post them in the comments. If this video helped, please consider liking it, and if you would like to be notified of new videos, make sure you subscribe. Thanks for watching, and good luck with your game.